We'll get started. Okay. We'll get started. Okay. So what was the last concept you saw? Vertical circular motion, right? That's done, right? Completely, right? Okay. So next topic we'll get started with this. Yeah. So the next topic we'll get started with this potential energy of a spring. Okay. So if you observe here, you have a spring, right? So here, if you observe, you have a spring which is connected to a block. Now, if you observe, this spring is to its natural length. That is, there is no force acting on this. And if you take the center of this block to be x is equal to 0, then you can say that there is no elongation in the spring. There is no extension or compression in the spring. So what is happening? Fs is 0. Fs means the force on the spring is going to be 0 and x is going to be equal to 0. Right. Now, if I extend it in this direction, right? If I move this block in this direction, then what is going to happen to the spring? It is going to get elongated. So when it is getting elongated, if I release it from this position, what do you think the spring is going to do? Obviously, the spring will try to pull the block in the backward direction. It will try to put the block back in the equilibrium position, right? Because the spring always wants to be at its normal length, right? So here, let's say there is an extension of x that is created where the extension is positive. But what will happen is there will be a spring force that will come into picture, which will be exactly acting in the direction opposite to the extension. In the sense, if you created an extension in the rightward direction, there will be a spring force that will start acting object in the leftward direction. And if you observe the value of that spring force, right, if you write it as Fs, then Fs is observed to be directly proportional to the amount of extension you have created in that spring, right? So when you remove the proportionality symbol, then you will have Fs is equal to minus k into x, where this k is what is called as spring constant. So it's called as spring constant. And here the negative sign indicates, so the indication of negative sign is that Fs and x are always in opposite direction. Okay. So this is the conclusion we made with the help of extension concept. Now what will happen is, if I assume that the spring is compressed, means instead of applying a pulling force, let's say you applied a pushing force, then what will happen? The spring is going to get compressed. From where? From its mean position x is equal to 0, the spring has got displaced through a distance of x in the leftward direction. Now, in this case, I can take x to be negative because with respect to this origin, anything on the left is considered negative, right is considered positive. Now, if you remove the force, if you remove the external force from here, what will happen to the block? The block will get pushed to the right. See, it is because of the external force we compressed it. If you remove your hand, what will happen? The block will get pushed away. And why is it happening? It is because of this spring force. And here also, if you observe, the spring force is positive and the x value is negative. So what does that indicate? That the spring force and the displacement are always in the opposite direction. So that's why we get Fs is equal to minus k into x, where k is called as the spring constant, right? So what is going to be the unit of k? If you observe, if I ignore the minus sign here, I can write k is equal to spring force divided by x. So spring force is going to be measured in terms of Newton and x is measured in terms of meter. So Newton per meter or Newton meter inverse is going to be the SI unit for the spring constant. Am I clear with this? So whenever they give you the value of spring constant, they should always give it to you in terms of this Newton per meter. So this is the basic introduction of what is the force that comes into picture when a spring is either elongated or compressed. Okay. And the force that you need to remember is going to be this value. Am I clear with this? Right? So first make a note of it.
Sir, I can't hear you.
Okay. Am I audible now?
Yes, sir. Yes, sir.
Okay. So what I was saying is, now we will calculate the potential energy of a spring. And for energy, we do not have a direct formula. Rather, we are going to calculate the amount of work that is done by the spring or work that is done on the spring. Right. So since I need the potential energy of spring, I need to calculate the work done by the spring force. What do I need to calculate? We need to calculate work done by the spring force. Right. So what is the value of spring force? F is equal to minus K into X. Right. Now, let's say there is a spring like this, which is elongated from X is equal to 0. It has got elongated to a distance X. So there is going to be a spring force that will act in this direction, which is given as Fs is equal to minus K into X. Am I right? So Fs is equal to minus K into X. Now let's say the spring is further displaced through a small distance dx. So from x, it is further displaced to a small distance dx. Then what is going to be the amount of work that is going to be done by the spring force? So we know that dw is equal to, it is going to be minus fs into dx. Am I right? So we know that work done is equal to force into displacement, but here the work done is going to be small amount of work that is done, that is dw. So dw will be equal to minus fs into dx, right? So dw is equal to, what is the value of minus fs? It is minus kx into dx. Now, for me to find the total work done, I need to integrate it. So when I do the integration, I get w is equal to integral of minus kx dx. And where is the spring displaced from? Initially, the spring was at a distance of 0. The elongation in the spring was 0. And let's say it is extended to a maximum value of xm. So 0 is going to be the initial elongation or compression, and xm is going to be the maximum elongation or compression. So when you solve this, you will get w is equal to, I'll take the minus k outside, integral of 0 to xm, x times dx, it is going to be minus k into x square divided by 2 between 0 to xm. So between 0 to xm. So this will be equal to minus k into xm square, the whole divided by 2. So this is going to be the amount of work done, that is work done by the spring force. And this will be the amount of energy stored in the spring, which is what is called as the potential energy of the spring. Or there's a potential energy stored in the spring. So whatever work is being done will always get converted to some form of energy. That's what is happening here. Is that clear? So there is a derivation. I can make a note of.
Sir, what is XM?
What is?
XM.
XM is maximum elongation or
So
compression.
X and X.
X subscript M. M stands for
So it's a total elongation.
Yeah, it's a maximum elongation or maximum compression. Beyond that, you cannot compress the spring. Beyond that, you cannot elongate the spring.
Okay.
Yeah. Done? Done with this? Right. Shall I proceed? See, now if you are going to plot a graph between the spring force and displacement, let's say we need to plot a graph between the spring force and the displacement, where obviously the spring force is taken on the y-axis and the displacement is taken on the x-axis. So spring force on the y-axis, x on the displacement on the x-axis itself. So we have the mathematical equation for Fs as minus k into x. So there is a mathematical equation like this: y is equal to minus mx. So y is equal to minus mx basically represents a straight line passing through the origin, right? It is going to be a straight line passing through the origin, and it is going to be in the second and the fourth quadrant. Because of this minus sign, what will happen is this graph will belong to the second and the fourth quadrant. So why it is happening, you will learn it in your math called in a chapter called as straight lines. In straight lines chapter, you will understand why it is confined to my second and the fourth quadrant. So here Fs is equal to minus kx is this graph, right? But we know from the basics of the graph between the force and the displacement as if you calculate the area under the graph, right? If you calculate the area under the Fs graph, what is going to give us? It is going to give us the amount of work done. But we know that the amount of work done will always get stored in some form of energy. So for that, what I'm going to do is, if I take this to be the initial position of the object, which is 0. So initially there is no displacement. And let's say there is a displacement of xm, which is a maximum elongation or compression that is possible. From here, okay, from here, I'm dropping a perpendicular like this, right? So when you drop a perpendicular, after you drop a perpendicular, you see that you have the shape of a triangle, right? You have the shape of a triangle. Now, how much is this height going to be? So we say that the equation of this line is Fs is equal to minus kx. So what is the value of x here at point B? What is the value of x at point B? It is going to be xm. So this height is going to be minus k into xm. Okay. So this height is minus k into xm. And this distance is xm. So what is the area of a triangle? Area of a triangle is half into so area of a triangle is half into base, that is going to be xm, into height, which is going to be minus k times xm. So what are you going to get? You will get the answer as minus k into xm square divided by 2. If you observe, this is the exact expression we got in the previous case. Right? This is how we derived, no? This is what we derived. And this is also called as the energy stored in the spring, which is represented by the symbol U. We know that potential energy is represented with U, right? So this is going to be the answer for it. Okay, this is another way of interpreting the same derivation or the same equation. Okay, just make a note of it. Done? Those are online. Are you done?
Yes, sir.
Yes, sir.
So there are 2 points that we need to remember with respect to spring force. What is it? One is the spring force itself is given by the expression minus k into x. So for spring force, don't write it as minus k into xm. It is minus k into x, where x can vary anywhere between 0 to xm. It can be anywhere between the least to the maximum value. Whereas when you talk about the energy that is stored in the spring, it is going to be minus k into xm square divided by 2. So it will be minus k into xm square divided by 2. So based on these two expressions, we will try to solve some problems. Where the first problem is two springs have force constants. So spring constant is also called as force constant, which are K1 and K2, where K1 is greater than K2. So there are two springs where you have K1 to be greater than K2. On which spring is more work done if they are stretched by the same force? Right. So they are stretched by the same force. Fs is equal to minus K1 into X1. And Fs is equal to minus K2 into X2. So why did I write it like this? Because the force is supposed to be the same. Right. So the meaning of it is they're asking on which spring is more work that is done. Can you tell me? Why? You're saying K2, there is less work done or more work done? More work is done. So what is the logic? Can you come again? K1 is? Okay. Is it so? Think about it. So I want a better answer. Think. So whenever you have these, I'll give you a hint. You know, so I told you there are only two equations to be remembered. What are they? Minus kx, and the second is minus half kx square. So what are they asking the question? They're asking something related to work done. So they need the work. We need to find what is the relation between the works being done when the same amount of force is being applied on both the objects. So find it out and tell me. So support it with the mathematical equation. At least tried. Except one, nobody is even bothered to try. Try. Now tell me what is the answer. See, question is on which spring is more work done if they are stretched by the same force. So what is the formula for work done? W1 is equal to, so ignoring the minus sign, can I write it as half K1 x1 square. Right? What about W2? So W2 is equal to half K2 x2 square. Right. So whenever you want to find which work is greater, do a comparative study. For that, what I'll do is I'll write W1 by W2. So W1 by W2 is equal to half K1 x1 square divided by half K2 x2 square. Half and half are gone. So can I write this as K1 into x1? Because I have K1 into x1 into x1, the whole divided by K2 into x2 into x2. Can I write it like this? So what is K1 into x1? F1 or Fs, and here also you have Fs. So here you have x1, here you have x2. So Fs and Fs will get cancelled. You will have x1 divided by x2. Right? But you can clearly understand when force is going to be a constant, when you have product of two values. See, here can I say K1 x1 is equal to K2 x2? Can I say K1 x1 is equal to K2 x2? So x1 by x2 is equal to how much? K2 by K1, right? So x1 by x2 is equal to K2 by K1. But what is the ratio of them? So if you observe, K1 by K2 is greater than 1. So K2 by K1 is less than 1. So W1 by W2, when you started writing like this, you got K2 by K1. So when K2 by K1 is less than 1, W1 by W2 will be W1 by W2 will be less than 1. So W1 is less than W2. So W1 is less than W2. So what will happen in this case, when the springs are stretched by the same force, work done in the first case will be less compared to the work done in the second case. Okay. So this is the answer for the first part. Am I clear with this? Right. The second part is, if they are stretched by the same amount, means the elongation or compression. So here when they say stretched, it is the elongation, right? So when they are stretched, right, W1 by W2, what are you going to write? You will write it as half K1 x square divided by half K2 x square. So half and half will get cancelled. X square and x square will get cancelled. You will get K1 divided by K2. But you know that K1 is greater than K2. So K1 by K2 is greater than 1, which implies W1 is greater than W2. Is that point clear? So W1 is going to be greater than W2. Okay. So these two. So in this case, the first case W1 is less than W2, and in the second case W1 is greater than W2. Okay. Make a note of it.
So can you show the next one?
Done. Are you done copying? This one,
Yes, sir.
you're done? Okay. Okay. Next. Try this. So this should not take more than 2 minutes. Do it fast, read the question carefully and do it. So the length of the steel wire increases by 0.5 centimeter when it is loaded with a weight of 5 kilogram. Calculate the force constant of the wire. And second is work done in stretching the wire. So length of a steel wire is, increases by 0.5 centimeter when it is loaded with a weight of 5 kilogram. So what is the answer for spring constant? What formula are you going to apply? Fs is equal to mass into. Okay, what acceleration are you going to put? It's clearly extending because of what? So what acceleration will you put? Acceleration due to put it. How much? 40. 49 is weight. I'm asking what is the spring constant? You can take the value of G as 10 if you want. So this one. So there is a steel wire, right? There is a steel wire which has its original length L. Okay. When you suspended a load of 5 kilogram, it got elongated by how much distance? It got elongated by 0.5 centimeter.
So 10 into 10 power 3. So 10 power 4.
So let's see. So it is happening because of the weight. So all that we need to do is we are saying that the weight that is exerted by the mass or the weight experienced by the mass is what is going to get stored as the spring force. So mg is equal to k into x. Right. So what is the value of k? So k will be equal to m is 5 into g is 10, the whole divided by what will you take the value of x as? 0.5 into 10 power minus 2. So 0.5 will cancel this 5 10 times. So 10 square into 10 square, answer will be 10 power 4 Newton per meter. So it will be 10 power 4 Newton per meter. Okay. Next is calculate the work done in stretching the wire. So for calculating the work done in stretching the wire, work done is equal to half into k x square. So half into the value of k is 10 power 4 into x square is how much? 0.5 centimeter. So 0.5 is half. Half into 10 power minus 2 the whole square. So half into 10 power minus 2 the whole square. Why did I put that? Because I converted centimeter to meter. So what will you get? You will get 1 by 2 into 10 power 4 into 1 by 4 into 10 power minus 4. 10 power minus 4 and 10 power 4 will get cancelled. It is going to be 1 divided by 8, which is 0.125 joule. No need of minus here. It is only work done. No energy is minus. Okay, here we need only the magnitude. Right? So it is going to be 0.125 joule. Okay. Clear with this? So I want you all to work fast. Do this. X is, let me check. I think it is 10 joule. 10 joule. The potential energy of a spring when stretched through a distance of x is 10 joule. What is the amount of work done on the same spring to stretch it through an additional distance of x? Yeah. Rohit, என்ன பண்ற? எவ்வளவு நேரம் படிக்கிற question? How much time are you going to read the question? It's data எழுதுனியா நீ? Try hours பண்றியா first of all? டுவெண்ட்டி வராது. Question நல்லா படி. What is the amount of work done on the same spring to stretch it through an additional distance of x? X இல்ல 2x square வராது. அது எப்படி 2x square? So you're saying you're rearranging this. So you're saying kx square is 20. அப்ப என்ன பண்ணணும் அடுத்த ஸ்டெப்ல? So additional distance of x அப்படின்னா 2x எடுத்து பண்ண. So இது கேஸ் நம்பர் 1. இது இனிஷியலா நடந்தது. கேஸ் 2 பண்ண.
Sir, 30 joules.
Correct. 40 is correct. எதுரா?
30 joules இல்ல sir.
30 வராது.
Sir, you'll get 40 when you.
Actually, yeah. What is the amount of work done on the same spring to stretch it through an additional distance of x?
Minus the 10.
So you're doing 10 minus, okay. Yeah, correct. See, actually, I read the question as what is the work done on the same spring to stretch it through an additional distance of x? That is 40. So already when you elongated it through a distance of x, it is 10. So what is the extra effect that you put? 30 is the answer. So 40 minus 10. Because the question is what is the amount of work done on the same spring to stretch it through an additional distance x? So means you already extended through x. You already did 10 joules of work. From 10 joule, how much extra work are you supposed to do to elongate it to 2x? Did you get the answer? Right. You have to apply only one formula. Read the question carefully. You will be able to do it. It's only 2 steps. So here the question is, the potential energy of a spring when stretched through a distance x is 10 joule. So what is the potential energy of the spring? A spring in the first case, U1 is equal to half k x square. Then how much is this value coming out to be? This is equal to 10 joule, right? So what we are trying to say is work done to extend the spring from 0 to a distance x is 10 joule. Now the second case is, what is the amount of work done on the same spring? When they say same spring, what is the meaning of it? The spring constant is the same. Because for a spring, the spring constant is fixed. So that is the meaning of when they say same spring, it is stretched through a distance, an additional distance of x. So if I observe, U2 is equal to half k into, how much is it going to be? 2x the whole square. Means I am calculating the energy that is getting stored when the spring is extended from 0 to 2x. So from 0 to 2x, how much is the energy that is going to get stored? It will be 4 into half kx square. But we know that half kx square is 10. So it will be 40. So when the spring is extended, so observe, this distance is x, and let's say this is going to be 2x, right? They're asking how much work are we supposed to do to extend the spring from here to here? When you want to extend the spring through an additional distance of x, right? So here already how much is the energy that is getting stored? Here it is 10. So in this total, there is an energy of 40. So how much work should be done to extend it from A to B? 40 minus 10, it will be 30 joules. So how you will write it is, work that needs to be done is equal to the change in potential energy, that is going to be U2 minus U1, or this can be written as 40 minus 10, which is going to be 30 joule. That's the answer. Is the point clear? Right? So do one more problem based on this. Yeah, this is a textbook problem. Okay, just give me a minute. You keep reading the question. To simulate car accidents, auto manufacturers read all those things. Now it makes sense. Read the question. Read it. So to simulate car accidents, auto manufacturers study the collisions of moving cars with the mounted springs of different spring constants. Consider a typical simulation with a car of mass 1000 kilogram moving with a speed of 18 kilometers per hour on a smooth road and colliding with a horizontally mounted spring of spring constant 6.25 into 10 per 3 Newton per meter. What is the maximum compression of the spring? Okay, at least try to draw a diagram and understand how it works.
The compression is displacement, sir. So X.
Sorry?
Compression is X, no, sir.
Uh,
I got the answer as 2.
who's right answer? There's actually an NCERT problem as well. Try to draw the diagram, you'll understand it. Thanks. See, listen. So this question is to So the question is, to simulate car accidents, auto manufacturers study the position of moving cars with mounted springs of different spring constant. In the sense, let's say there is a spring like this, right? So what they will do is they will try to replace these springs with different spring constants. And what is going to be there? There is a car of mass, how many kilograms? There is a car with a mass of 1000 kilogram moving with a speed of 18 kilometer per hour, right? So it is moving with a speed of 18 kilometer per hour. So what is going to be the value in terms of meter per second? V is equal to 18 kilometer per hour means it is 18 into 5 divided by 18. So 18 and 18 will get cancelled. It will be 5 meter per second. So it will be 5 meter per second. Now, this car is moving on a smooth road and colliding with horizontally mounted spring of spring constant. How much value? 6.25 into 10 power 3 Newton per meter. So K is equal to 6.25 into 10 power 3 Newton per meter. Now what will happen is this car will get collided with this spring and it will compress the spring. So till what extent can it compress? Till a certain value of xm. Now they are asking what is the maximum compression of the spring. So for that, the expression is very simple. Tell me which energy is getting converted to another energy. Kinetic energy is what is initially present for the system. Kinetic energy is getting converted to when the maximum compression has taken place, what will happen to the car? It will stop. So kinetic energy is completely getting converted to the elastic potential energy. So kinetic energy is equal to the elastic potential energy. So that implies what is going to be the kinetic energy? It is half mv square is equal to what is the potential energy? It is half k x m square. In this case, I'm writing it as half m x m square. Am I clear with this? So listen to this. We know that the formula for u is equal to minus half k x m square, right? Listen to this very clearly. There are two theorems in this chapter which I already discussed. One is going to be energy conservation and the second is the work energy theorem. You remember? Right. Listen, whenever you are applying the energy conservation theorem, do not apply minus sign to any of the energies. I repeat it, whenever you are applying energy conservation theorem, do not apply the minus sign to any of the energies. Whereas when you are applying the work energy theorem, you need to take the minus sign of that energy into consideration. Is the point clear? So half and half will get cancelled. mv square is equal to k times xm square. What is the value of m? It is 1000 into v square is going to be 25 is equal to k is 6.25 into 10 power 3 into xm square. So 1000 and 1000 will get cancelled. So 25 into 6.25 is going to be equal to how much? 0.5. Right? It is 0.5. Sorry, it is 0.25. Is going to be 0.25. So which is nothing but xm square 0.25 can be written as 1 by 4. So 1 is equal to xm square by 4, which implies xm is equal to or xm square is equal to 4 or xm is equal to 2. So it will get displaced through a distance of 2 meter. Am I clear with this? Right? So mark it as an important problem. Right. I'll be honest on your face. I'm not happy with the physics performance. Yes. I'm not happy with your performance, sir. Purida, Puridia. Okay. So I'm going to take the test also very seriously. Day. Is that clear? I'm going to sleep. And next week, please be prepared with the Newton's laws of motion. Is that clear? It's not going to work. I'm going to closely monitor everything. And don't write the test from home. Only if you're staying few kilometers away or in another city, you can attempt. Otherwise, come here and write it. I'm very particular about it. The next week test, I'm going to monitor it closely. You know, I'm not able to do the problems faster. No, for me, explain money. To be honest, I'm getting bored to explain. Except that guy, one guy is doing fast, another speed, and one more online. The speed is not sufficient. The problem is you people are not worried to try also. That is bothering me even. At times I feel, why am I even teaching you? I think time waste funny so I would rather spend my time on 12th grade and my energy. Correct தானே? பண்றியா உன்னது? இல்ல இல்ல. Be honest and tell me. Try பண்றியா? இல்ல இல்ல. நீடா? சரி அப்ப கேட்கலாம்ல கேட்கலாம்ல இந்த பாயிண்ட் புரியல அப்படின்னு வாய் திறந்து கேட்கலாம்ல have I ever told anything unless and until I understand what you understood or what you didn't understand how do I teach something இப்ப spring constant புரியலன்னு வெச்சுக்கோங்க I will change my method of teaching at least if you ask a question, right, I can change, I'll immediately change my method of teaching. I'll bring something and show an example and teach. Actually, there's something I was doing for 12th standard. Something I was doing for 12th standard and showing. At least they paid attention. I could show something. I think I've tried multiple times to showcase. That's I try to teach you guys. But understand you're wasting my time also. You're coming here for time pass, your parent. You please don't come, you can stop. I don't mind. I don't want those kind of people also. If you're ready to learn something, you want to be different from people, then please step in. I'm losing my interest to teach, I'll be very honest. Thursday, Friday, my energy levels are going down. You can come and see how I teach for 12th. You can come and sit. You can see my energy levels. I'll give you that permission also. Andro full of free you can come and sit, see how I'll teach for 12th standard, how I'm teaching you people. It's really bothering me, I'm telling you. Better make a decision, okay? Don't waste my time also and your time. If you don't get the subject, I can understand, I can help you. But if you're not trying, I can do nothing. One problem I give you, people are sitting and talking, looking into others' books, not even trying. If you don't get, not bother to ask me, now how do you expect me to understand? First of all. First question, I was completely, I lost it. Only he was trying to answer. Others I saw, none of you are even bothered to try it. I'm worried. 11th is actually tougher, and I don't want to scare you. 11th physics, I'll write and give you, it is tougher. Teaching is also tougher, and learning is also tougher. With this effort, you think you can do something in life, you can do nothing. Now, when I'll put a counseling session of your seniors for you guys, you can learn from them of what mistakes they did. 2 days back, I had a counseling session. One guy was telling me I made a mistake. 11th படிக்காம எனக்கு 12th ஒண்ணுமே பண்ண முடியல. You want to sit and cry for your 12th standard, you cry. I have nothing to do. You're literally wasting 365 days of your time. Your time, please understand. என் டைமை கூட விட்டுரு. வேல்யூ தெரியலன்னா I'll accept it. At least respect your time. For the effort you're taking all the way, traveling and coming here, sitting here, learn something and go. No, that is what I'm asking. Every class it is getting downgraded. How can I tolerate it? நீயே சொல்ற 7th chapter ஈஸியா? இதுல ஒண்ணும் இறங்காது. நான் எழுதி தரேன். Nothing will go into your head. 7th chapter. You will feel that physics is torturing you. I'm telling you again, my problem is if you don't understand, it's not an issue for me. That is my headache. If you don't understand something, I have to teach you. Other than worrying, I'll take that responsibility. But if you're not even opening your mouth or not trying something, then why should I take extra effort to teach you is what my question is. That's running in my mind. I'm directly putting the question to you people. Because I'm losing interest to teach. நான் தான் எதுக்கு இந்த கிளாஸ்ல இருக்கணும்? I'm thinking. Why should only I teach you people? இந்த லட்சணத்துல இருக்க நான் எதுக்கு சொல்லித்தரேன்? And you people don't even know how much time it takes for all these questions to be taken, PPTs to be created. Shall I show you how much work goes in? You see the people roaming around, right? They're not simply roaming for time pass. They sit for hours together and create all these things. At least no, open your mouth and say, are you able to understand? பண்ண முடியுதா? இன்ட்ரெஸ்ட் இருக்கா இல்லையா? Why are you sitting here? Do you have answers for these questions? எதுக்கு உட்காருங்க? வீட்டுல அனுப்புறாங்க, வந்துட்டேன் அப்படின்னா வராதீங்க. தயவு செஞ்சு வராதீங்க. I'll talk to your parents. I don't need such people at all. If you really have some respect for yourself, your time, you want to learn something, please come down. I'm very clear about this point. I'm very vocal about it. I don't mind. Online though, it is torture for taking for you guys. Only one or two will open your mouth and speak. Others, I don't know what you people do sitting on the other side. Do this. You don't understand, open your mouth and ask. By looking at that question, I'm expecting one question to come from you now, immediately. Hello, mistake. Mistake, something that is not clear. What is that? Consider example 38 and example 38 is there. Example 38 எங்க இருக்கு? நான் example 38 ஏதாவது பண்ணனா? It is actually the previous problem. So it is actually consider P4, problem 4. So in problem 4, what did you understand? So in the previous problem, what did they give? What kind of a surface on which the car was moving? So instead of smooth surface, if you have a rough surface, then what will be the change in the value of the maximum compression? So I'll ask one question, answer this properly. In the previous case, what is the value of maximum compression that you got? 2, right? So when the surface was smooth, you got the answer as 2 meters. Now you have the coefficient of friction. So do you expect the answer of your XM to be greater than 2, less than 2, or exactly 2? It should be less than 2. Why is it so? So the car has to overcome the work done by the friction also, right? So tell me one more thing. In the previous case, I told you, what concept did I apply to solve the previous problem? I put the equation, I told you what that equation and what theorem it is. You nodded your heads also. I wrote half mv square is equal to half kx square. Half mv square is equal to half kx square. I told you what theorem it is. I told what theorem. I didn't. I told there are 2 theorems in this chapter. What are they? And the energy, what this case? Energy conservation. I could apply energy conservation because both are conservative forces. But what does work energy theorem? When can you apply work energy theorem? Whether you have conservative or non-conservative, you can still apply work energy theorem. In this case, can you solve this problem using energy conservation? No. Why? You need to think all these points, right? So you apply what is the work energy theorem here and then solve it. Sure. Numbers, Venma. Numbers, sir. I'm saying you cannot apply this. You cannot apply this theorem. Why? Because it is the energy conservation theorem. It is applicable for a smooth road when all forces are conservative. Since friction is there, what does work energy theorem state? Work done by whom? Work done by all the forces. Yes. Anybody, those who are online, could you do it? Could you frame the equation?
Sir, I got the equation. I cannot
solve
do
it.
a numerical one.
So equation,
Half kx square plus mu mgx equals to half mg square.
half kx square plus mu mg square is equal to
Mu mgx equals to half mg square.
correct. That's right. You proceed. Solve it. The question is, consider problem number 4, and in that, take the coefficient of friction to be mu, right? And its value is 0.5. So take the value of mu to be 0.5 and calculate the maximum compression of the spring, right? So what is happening here? Again, you have the same simulation. There is a spring and there is a car which has 1000 kilogram, right? It is moving with a speed of how much value? 5 meter per second, and the spring constant K is equal to how much? 6.25 into 10 power 3 Newton per meter, right? So now we need to calculate the compression of the spring, provided there is a frictional force that is acting. So the surface is rough. So what does the work energy theorem state? It states that work done is equal to change in kinetic energy, right? So what is the formula of work done here? So what are all the forces that are doing work? Work done by the spring force plus what is the other force acting on it? See, when this car is moving, right, after it has collided with the spring, what are all the forces that are doing work on the car? One is spring. Second is friction. It has a contact with the floor, right? So plus work done by the friction is equal to change in kinetic energy, which will be the final kinetic energy minus the initial kinetic energy. Am I right? Now tell me, what is the work done by the spring? It is half K xm square, but we know it has a minus sign. So I told you, right, when you're applying the energy conservation theorem, do not take the minus sign into consideration. Whereas when you're applying the work energy theorem, you're going to apply the minus sign. So minus half K xm square plus what is the frictional force that is acting? It is going to be mu mg. So frictional force is mu mg and the displacement is xm. But they both are acting in the opposite direction because cos 180 will come into picture, right? So it is actually minus half K xm square minus mu mg into xm is equal to what is the change in kinetic energy? Final kinetic energy is 0 because the car has come to rest, minus what is going to be the initial kinetic energy? It is half mv square. Am I right? Correct. So here the minus sign is going to get cancelled and you're left out with half K is how much? 6.25 into 10 power 3 into xm square plus mu is how much? Mu is half 0.5. No, it is half into what is the value of m? 1000 into g is 10 into xm square is equal to half mv square. So half will get cancelled, right? Here also you have mass to be 1000, no? So is equal to half into 1000 into v square is 25. So half will get cancelled and 10 power 3 will get cancelled. Am I right? So 6.25 xm square plus this xm, right? Yes. Plus 10 times xm is equal to 25. Actually, you have a quadratic equation, right? So for this quadratic equation, we need to calculate the roots. Okay. So I'll tell you how to do it. Listen. So 6.25 will get cancelled by 5. How many times? 1.25 times. And 10 will get cancelled 2 times and 25 will get cancelled 5 times. So 1.25 xm square plus 2 xm is equal to 5. Right? I'll tell you how to handle this. Observe. So what is it? 1.25 xm square plus 2 xm is equal to 5. See, 1.25 is there means you can write it as 5 by 4. 1.25 is 5 by 4, which implies 5 by 4 times xm square plus 2 times xm is equal to 5. So take the 4 to the other side. So what will you get? 5 xm square plus 8 xm minus 40 minus 20 is equal to 0. Right? 4 into 5 is 20. It will come to the left hand side. Now what do you have here? 5 into 20 is going to be 100. So 100 means what are the factors that you can take? 10 and minus 2 will give you only 20, no? So 1.25 into 4 divided by 4, 1.25 into 4, yeah, 5 by 4. So 5 by 4 xm square plus 2xm is equal to 5. So this is what you have got. So 100 means what factors will you take? So you exactly do not have factors here, right? You do not have factors here. So you need to apply the formula. Xm is equal to minus b minus 8 plus or minus root of b square, that is 64, minus 4 into a into c, the whole divided by 2a. Am I right? So minus 8 plus or minus root of 64 plus, this is going to be 100 into 4, which is 400, the whole divided by 10. Right. So it will be minus 8 plus square root of 464 divided by 10. So how much is 464 square root? 484 square root is 22. So it will be 21 points. So how much will it be? It will be 21 point something. So what you can do is, so I didn't take the minus here because, see, I didn't take the minus here because if this is negative, this is also negative, then the compression will become negative because this is distance. Xm is distance, not displacement, right? So I took the plus value. It will be 21.8 minus 8, the whole divided by 10. So 21.8 minus 8 is going to be 13.8 divided by 10. Answer should be 1.38 meter, as we discussed, right? The value of elongation, the value of compression should be less than 2 because of the frictional force coming into picture. So it came out. So there is the answer. You're clear with this? Right? So if you observe this problem, right, one important thing is, with this physics part is over. Everything else is mathematical part. Okay. So when you solve a problem, mostly whenever you see, most of the problems you can solve it not only in this chapter. Most of the problems you can solve it with the help of energy conservation and work energy theorem itself. Most of the problems. I'll tell you how to do it. Okay. So first copy this. Puritam. Done with this? Copy. Listen. So listen, I'll tell you what is the power of these two theorems. You all have the notes for projectile motion. The same book. You all have it? Okay. So check what is the formula for the Mach U square sin square theta. Right. See, when I take a projectile into consideration, okay, listen. When I take a projectile into consideration, so let's say it is projected with initial velocity of u, making an angle theta with respect to the horizontal, right? So it is going to reach a maximum height here, which is given by the expression u square sin square theta divided by 2g. So how did we derive this? So one is observe. So one of the ways in which this can be derived is using the equations of motion. So we use the equations as v square minus u square is equal to 2as, and we applied it along the y direction. Right, we applied this along the y direction, which implies velocity of the object at the highest position is how much in the y direction is 0. So it is 0. So 0 square minus what is the initial velocity of the object along y direction? See, this is u cos theta and this is u sin theta. So initial velocity of the object along y direction is u sin theta. So 0 square minus u square sin square theta is equal to 2 into, see, if you take the upward direction as positive, g is in the downward direction. So it is minus g into how much is the distance covered by the object? It is h max. So this is the formula for h max, right? So it is minus u square sin square theta is equal to minus 2g into h max. Accepted, minus and minus will get cancelled. So what will you get? This implies h max is equal to u square sin square theta the whole divided by 2g. So this is the way we derive this expression for when we chapter, right? Now, extra, can we try to derive the same thing using some other logic, right? So can we try to derive the same thing with the help of energy conservation? So what does the energy conservation theorem state? So kinetic energy plus potential energy at every point should be a constant. So if I take this point to be O and this point to be A, right, observe this carefully. Can I say that the total energy of the object at O should be equal to the total energy of the object at point A? So what is the energy possessed by the object at point O, provided I consider the base to be the reference line, because for potential energy, I need the reference line. So what is the total energy at point O? It is going to be the kinetic energy at O plus the potential energy at O. Can I write it as equal to kinetic energy at A plus the potential energy at point A? Can I write it? So what is the kinetic energy at point O? It is half m. You will not write half m u sin theta square or half m u cos theta square. It is a sum of both. It is only half m u square. So it is half m u square plus what is the potential energy of the object at point O? It is 0 because that is the reference line itself, is equal to what is the kinetic energy at point A? It's not 0 because it is only the vertical velocity that is 0. E by 2. That will not be the case. So here, if you observe, it is going to be u cos theta. There is a horizontal velocity existing for this particle, no? So though at the vertical point, only the vertical velocity is 0, but the horizontal velocity is still u cos theta, because that is constant everywhere. The object does not accelerate along x direction. So can I write this as equal to half m, since this is the only velocity existing, so half m u square, so that is going to be u square cos square theta. Make sense? Plus, what is the potential energy at point A? It is going to be mg into h max. So what gets cancelled? M is gone. So half I will leave it as it is, or half u square I will leave it as it is. So if I take the u square common, here the value is 1, and here the value is cos square theta. So when it comes to the left hand side, it will become minus cos square theta is equal to g into h max. So what is 1 minus cos square theta? So this implies u square into sin square theta by 2, u square into sin square theta by 2 is equal to g into h max. Bring the g to the left hand side. U square sin square theta by 2g is equal to this, and this are the same. Did you understand this? So what I'm trying to say is, this one theorem is enough for you to solve any problem where there are conservative forces. In the sense, if you don't even know the equations of motion, you can still solve it with the help of energy conservation. Am I clear with this? So those who are online, could you understand? Just make a note of it. Those who are online, could you understand?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yeah. Clear with this? Now this. Listen to this. Right. See, when you have only conservative force acting on the system, you can apply energy conservation theorem. But irrespective of whether you have conservative or non-conservative, you can apply the work energy theorem. So the third case is, I'm going to apply the work energy theorem in the same scenario between the points O to A. So what does the work energy theorem state? Work done by all forces is equal to change in kinetic energy. Now tell me, this object is moving under the influence of which force? Under the influence of gravity. By the gravitational forces mg h max, mg is acting downwards, the displacement is upward. Am I clear with this? So mg is downwards, displacement is upward. So what is the work done here? It is not positive work, it is negative work. If you forget this, you will not get the answer. So work done by the gravitational force in this case is negative. But if you observe, when I applied the energy conservation theorem, I took mg h max, but I didn't apply any sign. I always took it as positive. Whereas when I apply the work energy theorem, I'll take the work done to be negative, because work can be negative, positive, or zero. Energy is always positive. Okay. So this is equal to change in kinetic energy. Change is final kinetic energy minus the initial kinetic energy. So final is half m u square cos square theta minus, what is the initial? Half m u square, m gets cancelled. So minus g into h max is equal to u square by 2 into cos square theta minus 1. See, 1 minus cos square theta is sin square theta. Cos square theta minus 1 is minus sin square theta. So it is minus u square divided by 2 into sin square theta, which is minus g into h max. Minus or gone. H max will be equal to u by 2g. So you do whatever you want, you'll get the same answer. So why I'm trying to stress here is that is the power of these two theorems. Am I clear? Previously. So let's copy this and I'll show you. Leave some space. For 2 minutes. Others are copying. Will I show the previous slide? So those if not copy this, copy it. So there is one last concept left out in this chapter, which is collisions, that we'll discuss tomorrow. And for collisions also, all these things are important. Now work a derivation. First sound. Elastic collision, what is the final velocity? Value and V1 euro. Derivation of final value and plus or plus or M1 plus M2 or so. Okay, so that's all for today, and we'll wind up with this. So as I told you, next week you will have a test in Newton's laws of motion. Prepare it completely, especially from the notes that I gave from my class. Okay. Tomorrow? No, I'll put it in Newton's law. Yeah, I'll ask. Yeah, those are online. Are you all clear?
Yes, sir.
Yes, sir.
Okay, so my network got cut off. There are no doubts, we can wind up this session. You all can leave.
Thank you, sir.
Thank you, sir.
Yeah.